Good morning, good afternoon, good evening, depend on where you are watching me from or when you are watching this video. Yeah, I have to welcome you all to indices. In this video, we'll be talking about indices. Yeah, indices. I know some of you, your secondary schools, you were not properly taught indices. But here, I'm going to teach you indices that you know it more better than any other person. Are you clear? Yeah, so in this video, I'm going to teach indices. Then we'll also look at examples that will help you grow beyond your limits. Is that clear? Okay, let's go. Yeah, you know, in indices, uh, indices, when we say indices, let us have a base A and let us have power or index N. You know, we call this base, amen, and we call this index. But if this is more than one, we refer it as what? Indices. Is that clear? Or this is also known as power. Are you clear? Yeah. So, yeah. So we can refer this as what? Indices. But sometimes you will see indices in this form: ax times a raised to the power of n. This one too is an indices. Is that clear? So I just try to introduce, I want you people to know what is the meaning of this and what is the meaning of this. So we can call this a raised to the powers of what? N. Supposing like this one, we can call this one a raised to the powers of n. So what if we have it in this form? This is called a raised to power what? X. Are you clear? Then if we have it in this form again, this is called a raised to the powers of 2. Do you agree? And this is also called what? A raised to power 3. Then what if we have it in this form? We have it in this one. This is called a raised to the powers of 1 all over 2. But before I move further, I want to tell you and show you something. You know, some people used to write indices in this form. Instead of a raised to power 2, they write it this way. Mathematically, you are very wrong. Please take note. Is that clear? You are very wrong. The right form of a raised to power 2 is this. Then the right form of a raised to power 3 is this, not this. Please take notes. You know, most especially Malians, you know, after taking series of weed, what they are saying on the board is different from what their lecturer is writing down. Yeah. So please, I want you to take note. Yeah. So I just try to introduce how indices, how you are going to come across indices. Then, not only that, we can have indices of this form, negative power. If we have it in this one, how do we call this? A raised to the powers of -1. Not like this, so a minus 1. No, please don't write it this way. Is that clear? So, what if you we have it in this one again? This is okay, yeah. This is a raised to the powers of let me just okay, cube root of 2. Yeah, not Don't ever try it. This is a cube root of 2. Is that clear? So let us go deep in indices. Amen. Okay? Do you understand? Please, if you have any question, don't hesitate to ask. Okay. Yeah. We want to go into indices. Before you will be able to solve problems from indices, there are rules, there are laws that are guiding these indices. Let us just look at it in real life problem. Amen. Yeah. You know, in real life, if now a guy want to go into relationship with a girl, excuse me, you know very well that there are conditions attached to that relationship, two of us. Yeah, it's true. Amen. Yeah. So that is how. So you as a man, you must abide by the rules and regulations of your partner. Else, the relationship will not be smooth, and there will be no love, two of us. It means it means you cannot find the relationship. That's what it means. If we want to put it mathematically, you cannot find the relationship. The same thing applicable here in indices. There are rules, there are laws that are guiding indices. So before you be able to solve problems in indices, you must take note of the laws. Amen. You must take note of the laws. What are those laws? 1. Multiplication law. 1. Multiplication law. Multiplication law. Are you following? Multiplication law. You know, multiplication law is telling us that if the bases are the same, you know what base means? If the bases are the same, it implies that you should pick one of the bases, then add the powers, raise it to the one of the bases, and you add the powers. What do I mean by that? That is, let us have a simple example. Simple example, amen. That is, if we have assuming evaluate example. Let's look at simple example. If we have evaluate or simplify, whichever one, evaluate a raised to the power of n times a raised to the power n. What we need to do, we are to write solution. Amen. Then we write the question back, a raised to the power of n times a raised to the power of n. If I may ask, yeah, we are talking about multiplication law, true of us. How will you know that this problem is multiplication? You know, you don't need a prophet to tell you. What is the operation here? This. The operation here is times, which is what? Multiplication. So you must make use of this law. But sometimes it might not be in this form. Sometimes you might see it this way. Amen. Yeah. So as you can see, you know very well that this is not points. But in mathematics, this is dot. A dot means is 8 times. Is 8 times. Do you agree with me? Or sometimes it might even be in this form, a raised to the power of n, a raised to the power of m. Yeah. This one too is multiplication law you are going to apply. Why? Because these two are multiplying, and you know that the bases are the same. This is A, this is also what? A. Please take note. Is that clear? So let us begin to look at this idiot. So this will be equals to, you know, what the multiplication law is saying. If the bases are the same, you pick one of, here we have a, base a, base a. So we pick one of the bases, then we have to raise it to the powers of what? We have to raise it to the sum of the powers. That is, it means n plus n. That is the meaning of multiplication law. Do you agree with me? So, if you come across something like this, you don't need a prophet to tell you. This is what you are going to do. Okay, let's look at more example again. Example, another example. Simplify a raised to power 5. Okay, let's set it this way, times a raised to power 6. Okay, amen. A raised to power 6. Yeah. Do you know that this question, with this my explanation, you don't need a prophet to tell you. You can tell somebody without solving this particular expression, the answer, two of us. You can tell somebody. Yeah, because here we are going to use multiplication law. Why? Because of the multiplication. The operation here is multiplication in between the two bases, two of us. So you look at the multiplication law, you consider the multiplication law, that is a raised to the powers of 5 times a raised to the powers of 6, which means, since the bases are the same, right? We pick one of the bases, a raised to the powers of 5 plus 6. Then 5 plus 6. Mind you, you know very well that I'm not writing it this way. A 5 plus 6. Please don't ever write it this way. Mathematically, you are very wrong. Do you agree with me? You are very wrong. Is that clear? The reason why some of you failed mathematics, most especially NECO, WAEC, JAM, is because of this. You are solving it, yeah, you think you are right, but you are writing A5 plus 6. Yeah, that's the meaning of this. But this one is a raised to the power of 5 plus 6. Please take note. Is that clear? Yeah. Okay. So now you discover that we will add this to give us a raised to the powers of what? 5 plus 6 will give us what? 11. Are you seeing it? I'm not writing it A11. Please. This is A11. This is a raised to power 11. Take note. Okay. Yeah. So if you agree with me, that is multiplication law. Mind you, the multiplication law, you may not always see A. Sometimes you might see questions, example, another example. Amen. The basis might not be A. Sometimes you may see simplify x raised to power 7 times x raised to power minus 3. So if you want to consider this, you don't need a prophet. The same approach, is that clear? We'll make use of the same approach. We write solution. Let us write solution. X raised to power 7 times x raised to minus 3. I know very well that some of you are kind of afraid because of what? The minus sign. And this one does not have minus sign. So how come this one is having minus sign and want to make use of multiplication law? The reason why you are making use of multiplication law is because of the operation in between them. Do you agree with me? Is that clear? So now the operation in between them is multiplication. So we are going to apply the same procedure. So this will be equals to what? We pick one of the x. So x raised to the powers of what? 7. Then since multiplication means you add the powers, two of us. So 7 plus Mind you, here this power has what? Negative, true or false? Plus, minus, you put bracket. Are you following? So now what you need to do is this minus times this. Yeah. So plus times minus is going to give you what? Minus. I want you to take note of this. Plus times plus will always give you plus. Plus times minus will always give you minus. Minus times plus is going to give you minus. Minus times minus, it will give you plus. Take note of this whenever, if you want to know mathematics very well, you must take note of this. In algebra, you must take note of this. Is that clear? So take note of this. This will guide you always. Okay, so now you don't need a prophet to tell you. It means with this, we are following this. Plus times plus, plus. Plus times minus, minus. Plus times minus, minus. So it means x raised to the power of 7 minus what? 3. So this is equals to x raised to the powers of 7 minus 3 is what? Is 4. Amen? Do you agree with me? So this is how you are going to use multiplication law. Is that clear? You will use multiplication law. Yeah. Let me come up with another one again. Can I clean this? Okay. I can clean this, right? Okay. So, amen. Yeah. So if you know what I am doing, yeah, let me introduce two variables. Amen. Two variables. That is another example. Let's look at another example. I want to introduce two variables. That is simplify. Amen. Simplify x raised to power 2 y raised to minus 1 times x raised to power minus 4, then y raised to the powers of 5. Yeah, I know you have been waiting to ask this question. Yeah, here you discover that the basis, we have two bases. We have x and y. Here too we have x and y. The most important thing you have to consider is the operation in between them. Is that clear? What is the operation in between them? The operation in between them is multiplication. So you must make use of multiplication. Is that clear? The multiplication. So multiplication law, sorry. So we write solution x raised to power 2 y raised to the power minus 1 times x raised to the powers of minus 4 y raised to the powers of 5. Yeah. So now we are going to apply the same procedure irrespective of the basis. The same procedure. Is that clear? Even if there are 3 bases, 4 bases, the same procedure. You just pick one. Since here we have x, we also have x, true or false. So this, we pick one of the x raised to, what we have here, 2. 2. Since the operation between them is plus, so plus, what is the power here? Minus 4. Minus 4. Then we now consider what? Y. So y raised to the, what we have here? Minus 1. Then the operation in between them is multiplication. So we are going to add the powers plus 5. You are done. Chicken, father. Okay. So now what we are going to do is for us to sum or add them. So our x raised to the powers of yes, we now record this. You can now see that this multiplication is very necessary, true or false. So we here Plus times minus will always give you what? Minus. So 2 minus 4, then y minus 1, and y raised to the power of minus 1 plus what? 5. Yeah, so this will now be equals to x raised to the power 2 minus 4. We are going to have x raised to the power of minus 2, true of us. Then minus 1 plus 5. When you see negative sign in front of any value, note that you are owing. Look at it, minus 1 means you are owing 1 naira. Please take note. Is that clear? You are owing 1 naira. Then plus 5 means you have it. So plus 5, you have it. Is that clear? So now you are owing 1 naira. Then later you got 5 naira. You use this 5 naira to go and pay your 1 naira debt. How much will be left? How much? 4 naira. Are you still owing or not? You are not owing. You are no more owing. So it's going to be plus 4. But supposing you are owing, it's supposed to be what? Minus 4. Is that clear? So here we are going to have y raised to the power of plus 4. Is that clear? But this answer, you know, in indices, as long as indices is concerned, if we have a raised to the power of minus 1, this is the same thing as 1 all over. Why is it 1? Why is it 1 all over? It's because of this negative sign. 1 all over a. Is that clear? Raised to the power of 1. But it's not necessary you put the 1. But supposing we have a raised to the power of minus 2. This is the same thing as, because of this negative sign, it's going to be 1 all over a raised to the power of what? 2. So look at it here. Look at it here. We want to do something. So we can write this answer this way. Or, amen, or 1 all over x raised to the power of 2 times y raised to the power of 4. Then this is the same thing as, or this is the same thing as y raised to the power 4 all over x raised to the power of 2. Yeah, either you write this answer, or you write this one, or you write this one. This is how we are going to do it. That is multiplication law. So now I want to look at division law. I told you we are going to look at indices. So it's indices we are looking at. Is that clear? Then we begin to solve problems. Are you following? Okay. That is that. So let us consider division law. Division law. Let's consider division law. Let us consider division law. Amen. Okay. Division law. Division law. Division law. Division law. Okay. Amen. Okay. Yeah. Division law is the same approach, but the difference is you pick one of the bases, if the bases are the same, then you subtract the powers. So just like opposite of plus is what? Minus. That is what you are going to do. You know, in multiplication we use plus, but in division is minus we are going to use. Is that clear? So if assuming we have a raised to power n all over a raised to power n, you don't need a prophet to tell you if you are asked to evaluate or simplify this. You don't need a prophet to tell you. Is that clear? What you need to do is, this is division. This is the same thing as a raised to the power of, since the bases are the same, you pick one of the base, then raised to the power of n minus what? N. Is that clear? This is the answer, and this is how you are supposed to solve it. But sometimes you might see it in this form: a raised to the power of n, a raised to the power of n. You know, most students, some of you, you are very familiar with this. You know that this is division, but this one, you are kind of confused. This and this, they are the same thing. It's the same approach you are going to use. Take note. Is that clear? Because not always in this form. It might come in this form. Are you following? So now, this is the same thing as, it's the same approach. Since the bases are the same, you pick one of the bases, a raised to the powers of n minus what? Do you agree with me? Okay. Yeah. Another example. Assuming we have, amen. Assuming we have a raised to the powers of 2 all over a raised to the powers of minus 5. Amen. If we want to simplify this, we are asked to simplify this. If you are asked to simplify, we write solution. Solution, right? A raised to the powers of 2 all over a raised to the powers of minus 5. True or false? Okay. Now, we are talking about what? Division. So if you come across an expression of this one, what are you supposed to do? What are you supposed to do? Yeah. What should first come into your mind? What will first come into your mind? If I were you, think that this question is coming from where? Indices. True or false? Yes. This is from indices. Yeah. This is from indices. Why? How? Because indices is of this form. Then, since it is coming from indices, which of the law are you going to apply? Is it multiplication or division law? You don't need a prophet to tell you. As long as the operation here, in between them, is what? Is a division sign. So you are going to apply division law. So by applying division law, this will now give you, we are going to do the same thing. Since the bases are what? The same. So here we will have a raised to the powers of 2 minus, since it is division, minus, note that the denominator, the powers of the denominator has negative sign. So you must put bracket minus 5. Do you agree with me? Then this will now be, let us recall the sign. Minus times minus is going to give us what? Plus. So you discover that a raised to the powers of 2 minus times minus plus 5. Then this is equals to a raised to the power 2 plus 5. 2 plus 5 is going to give you what? 7, isn't it? So a raised to the power 7. This is the answer. Mind you, I did not write it this way, A7. This is A7. Please take note. Some of you, you are writing a raised to the power 7. Instead of a raised to the power 7, you are writing A7. They will mark you wrong. Please take note. And this is how some of you fail mathematics. Yeah, that is the simple truth. Nobody will admit this instead of a raised to power 7. It will mark you wrong because you don't know what you are doing. So please always be careful. Okay, so now we have done multiplication law, we have done division law. So, okay, assuming, if you may ask, what if we have it in this form? What if we have it in this form? A raised to the powers of minus 3, b raised to the power 5, all over a raised to the power 7, then b raised to the power minus 1. It's the same approach you will use. Is that clear? You will apply the same method. It's simple as ABC. Let's write solution. Amen. Solution. So a raised to the powers of minus 3, b raised to the powers of 5, all over a raised to the powers of 7, then b raised to the power of minus 1. Yeah. What will first come into your mind? Maybe you are not a mathematician. Yeah. If I were you, what will first come into your mind is, look at this. Look at this. Look at this. You don't need a prophet to tell you. This question is coming from where? indices. And since it's coming from indices, what are you going to do? What you will do is consider what is in between them. This one, they are dividing this one, two of us. So it's division law. You apply. You are going to apply division law. Here we have A, we have B. Here we have A, we have B. Yeah, supposing here there is no B, you know what to do. I'm going to explain it. Okay, so if we have it in this form, it means we pick one of the bases. Is that clear? So here will now be a raised to the power of minus 3. Always start with the numerator, please. I know some of you want to start with this number is greater than this, bigger than this. So you want to write 7. No, it's not like that. Start with what? The first one, the numerator. Is that clear? So here will be what? Minus 3. Then, since here is division, it's going to be minus 7. Then what do we have here? B raised to the power of 5. Amen. Then what do we minus, because of division, minus, open bracket, raised to the power minus what? 1. Minus 1. You close the bracket. Do you agree with me? So what you need to do is this is equals to a raised to the power of minus 3 minus 7. You know, I told you, if you see negative sign in front of any value, it means you are owing 3 naira. Then look at front of 7. There is negative value. You go back to go and borrow how much? 7 naira. So if you add it together, what are you supposed to have? Is it plus 10 or minus 10? It's minus 10 because you don't pay the debt. 3 of us. You borrow, this one too you borrow, this one too you borrow. So if you add them together, it's minus 10. So here will be minus 10. Then b raised to the power of minus times minus is going to be what? Plus 5 plus 1. Then this is equals to a raised to the power of minus 10. Then 5 plus 1 is what? 6, isn't it? B raised to power what? 6. Do you agree with me? So, or because of this negative sign, we write it this way. B raised to power 6 all over A raised to power 10. Is that clear? Yeah. So either you pick this answer or pick this one, whichever one you want to pick. So this is a division law in indices. Then the last one we'll consider is another one we'll consider is power law. Is that clear? Can I clean the whole of this up? Okay. Power law. Power law. Let's consider power law. We consider power law. Power law. Power law. Power law. Amen. Okay. Let's consider power law. Power law. Power law. Okay. So I can clean all of this, right? Let us consider power law. Let's consider power law. Okay. Now, power law in indices is simple as ABC. When we say power law, when are you going to use power law? When is power law applicable in indices? I want to show you. Listen. Okay. If we have a raised to the power of n, close bracket again, then we have another power. You discover that this is power. This is power, true of us. That is, this one too is power or index. Power, this one too is power or index. True of us. So in one expression, we have two powers, two of us. So cases like this, that is where the power law is needed. Take note. So if we have a raised to the power of n, open brackets, raised to power n. The power law states that since this is power, use this power to multiply this power. That is the meaning of the power law. How? That is a raised to the powers of n times n. So this is equals to a raised to the powers of n. Or one can write it, if you want to write it alphabetically, a raised to the powers of mn. I know some of you will ask n before n. So why am I writing mn? Is, let me tell you, this is multiplication. Multiplication means commutative. Is that clear? What do I mean by commutative? Commutative means if you have m to multiply n, this is the same thing as n times n. So it means this is the same thing as mn is the same thing as nn. They are all the same thing. Take note. Is that clear? Okay. Yeah. So that is a power law for you. Let us try another one again. Let's try another one. Assuming you are asked an example, I hope you are following. If you have any question, don't hesitate to ask. If we have, you are asked to simplify or evaluate, sometimes students in your class, your teacher or your lecturer will use the word simplify. This x raised to the powers of 2, open bracket, raised to the powers of 5. Then, in exam, your lecturer will now use evaluate x raised to the powers of 2 raised to power 5. I know some of you are confused. In the notes, you use simplify and exam. He has not taught us. Who told you? It's the same thing. He's telling you to look into this. Try to simplify it. It's the same thing. Is that clear? So don't allow these two words to confuse you. Are you following? Okay. So now we are asked to evaluate this. Let's write solution. Solution. X raised to the powers of 2, open bracket, raised to power 5. Do you agree with me? So it means questions like this, look at it. With my explanation, you don't need a prophet to tell you again, isn't it? You don't need a prophet. Why? Because already it's power law you are going to use, isn't it? It's power law, true of us. So we will use power law to simplify or evaluate this. So this means that this is equals to x raised to the powers of 2 times 5. True or false? Then this is equals to x raised to 2 times 5 is going to give you what? 10. Mind you, it is not written this way, x2 times 5. Then you write it, this one is Malians that normally write things like this. After taking series of weed. Amen. After taking series of weed, they don't know what is on the board again. So instead of writing it this way, they write it this way. They understand it better this way. So that is why they are writing it this way. The brain has been divided. So please and please, mathematics is not, you cannot write mathematics this way. This is the appropriate way you are going to write it. Okay, so is it difficult? Is it difficult? Okay, so now that is that for you. Okay, let's look at another problem. Let's look at more example. Assuming we have simplify root 3 open bracket raised to power 3. Yeah. Okay, I know very well that some of you are confused about this simple question. Okay, raised to power 3. How can we solve this problem? Amen. Yeah. Yes. You know that this question is coming from indices, true or false. But look at it. Which of the laws are you going to apply? Look at it very well. Is it multiplication law, division law, or power law? Which one? Okay. Yeah. I know you are confused because there is no power here. But mathematically, if you can see what I am seeing power here. Although I did not explain to you. But let me just show you something. Note that if we have square root of a, this is the same thing as a raised to the power of 1 all over 2. Please take note, very important. Is that clear? If we have cube root of a, this is the same thing as, because of what? Cube root, a raised to the power of 1 all over 3. Then what if we have 1 all over cube root of or fourth root of a? This is the same thing as 1 all over a raised to the 6 fourth root, 1 all over what? 4. Then this is the same thing as, I told you that if we have a raised to minus 1, this is the same thing as 1 all over a. It means 1 all over a is the same thing as a raised to power what? So likewise, if we have a raised to power minus 2, this is the same thing as 1 all over a raised to power 2. True or false? So if you can see what I am saying, it means this is the same thing as a raised to power of minus 1 all over 4. Do you agree with me? Do you agree with me? Excuse me. So you must take note of this. As long as power law is concerned, we will make use of all this. Is that clear? Then sometimes you may see 1 all over 5th root of a. Then you now see amen, open bracket, raised to the power of 3. Yeah, this is the same thing as 1 all over a raised to the power of what? 1 all over 5, close bracket, raised to the power of. Now, you can now see that we have what? 2 powers. So we apply what? Power law here. If we apply power law here, it means we are going to have 1 all over a raised to the power of 1 all over 5 times 3. Then this we're going to do as 1 all over a raised to the power of 3 all over 5. Then this is the same thing as a raised to the power of minus 3 all over 5 because of 1 all over. Is that clear? So I want you people to take note of all this because you might come across questions like this in subsequent lectures. Is that clear? In your class or anywhere you find yourself, as long as mathematics is concerned. So now, it's because of this question I'm trying to explain all these things. There are more that we will see. Is that clear? There are more that we will see. Yeah. So, okay. Let's just, the last one, let me just show you one thing here. If we have a raised to the power of minus 3, we are supposed to have, this is the same thing as, because of this minus, the 1 all over, this is the same thing as a raised to the power of minus 1, then times minus 3. Yeah, so, a, the powers of a carries what? Minus. So you need to multiply this. So this is equals to minus times minus is going to give you plus. 1 times 3 is 3. So this is the same thing as, a raised to the power of 3. Please take note. Is that clear? So you take note of all this as long as power law is concerned. Okay, so let's consider this. Let's consider this. So now, how can we simplify this? It means we must transform this. You know, I told you that root a, square root of a is the same as a raised to power all over what? 1 all over 2. So if we have square root of 3, this is still the same as 3 raised to the powers of 1 all over 2. True or false? It's true. So we have to simplify this way. So we can now write 3 raised to the powers of 1 all over 2, close bracket, raised to power what? 3. So now, this particular problem, we have transformed it into what? Power law, where we can use power law to simplify this problem. Please take note of all this. So this is equals to 3 raised to the powers of 1 all over 2 times 3. Then this is the same thing as 3 raised to the powers of, you know, when we have 1 all over 2 times 3, note that there is an invisible 1. Use the numerator to multiply the numerator. Use the denominator to multiply the denominator. So this means this is the same as 1 times 3 all over 2 times 1. Do you agree with me? So 1 times 3 is 3. All over 2 times 1 is 2. So we are going to have 3 all over 2. Do you agree with me? Okay. So if you agree with me, it means, yeah. So this is how we are going to simplify this. Now, that is a power law for you. So with this example, you'll be able to attempt questions. Okay, let's look at one question. 1 all over 5th root of, amen, 5th root of a, open bracket, raised to the powers of minus 2. Okay? So what we need to do, we write solution, right? Solution, 1 all over 5th root of 5, a, open bracket, raised to the powers of minus 2. As I told you, with what I've written down before, you don't need a prophet to tell you. So we are going to, is power law you will still use. Is that clear? So we need to transform this. So this is 1 all over a raised to the powers of 6 is 5th root. 1 all over 5, close bracket, raised to the powers of 2. Then we now apply power law. This is the same thing as 1 all over a raised to the powers of 1 all over 5 times minus 2. Amen? Okay. So now this answer will now be equals to 1 all over a raised to the powers of minus 2 all over 5. True or false? Then this is the same thing as, you know, I told you, if we want to bring it up, it means this is the same as a raised to the power minus 1 times minus 2 all over 5. So the answer, the final answer will now be minus times minus plus 1 times 2 all over 5 is the same as a raised to the powers of 2 all over 5. This is how you are going to break it down. Is that clear? And this is the final answer. Okay. So now, now we want to look at it this way. But do you know that we can rewrite this answer this way? We can rewrite this answer this way. A raised to the powers of 1 all over 5 times 2. So it means this is a 5th root of a, amen, raised to the powers of 2. So this and this, they are the same thing. So this is how you are going to approach in case of indices. You apply power law. Yes, let's look at the last but not the least. The last but not the least, let's look at zero law. Amen. Zero law. That is fourth. Zero law. Zero law. Right? Zero law. You know, zero law means anything raised to power 0 is 1. That is the meaning of zero law. So whenever you are applying zero law, take note that if we have 5 raised to, you are asked to simplify 5 raised to power 0. This means 1. Even if, assuming you have 5 raised to the powers of 6, close bracket, raised to power what? 0. You will still apply power law because this is the same as 5 raised to power 6 times 0, true or false. Then this is the same thing as 5 raised to 6 times 0 is going to give you what? 0. Then 5 raised to power 0. Then anything raised to power 0 is what? 1. Take note of this. Is that clear? Because sometimes you may ask to simplify, let's say, example, simplify, amen, simplify, sometimes you may see a raised to the powers of 5, do you agree with me, times a raised to power 6 times a raised to power 0. Yeah, you can come across questions like this. So what you need to do, this is coming from indices, true or false. So what you need to do is multiplication law. We write it down, a raised to power 5 times a raised to power 6 times a raised to power 0. Do you agree with me? But I told you that anything raised to power 0 is what? 1. So here will be 1. This is equal to a raised to, or if we say we want to apply multiplication law, since the bases are the same, it's the same answer you arrive at. Let us go by the multiplication law. 5 plus what? 6 plus 0. True or false? Then this is going to give you what? A raised to the powers of 11. True or false? Or if we want to do it this way, a raised to the powers of 5 times a raised to the powers of 6 times anything raised to the power 0 is what? 1. We write 1 here. Then we now apply power law here. The bases are the same. Use it to multiply the 1 here. So we pick one of the bases, a raised to the powers of 5 plus 6 times 1. So this is the same thing as a raised to the powers of 11 times 1 is the same thing as what? A raised to the powers of 11. True or false? So this is how you are going to make use of zero law. Sometimes you may say simplify, amen, simplify 1 all over square root of a all in bracket raised to the powers of 0. You discover that this is what? 0. So you don't need a prophet to tell you the whole of this thing is 1. Yeah, because all in bracket it affects all. But sometimes you may see questions like this, open bracket square root of a all in bracket raised to power 0. You discover that the whole of this, it means the denominator here is what? Is 1, isn't it? Because of raised to power 0, 1. So this is equals to 1. Please take note. So let's look at one problem before we call it a day. Is that clear? So that is indices for you. If you come across indices, at least with what I have taught and done here, I think it will go a long way. Example, simplify Amen. Simplify 9 raised to the power of 1 all over 2 all over 27 raised to the power of 2 all over 3. It's simple as ABC. Yeah. So now, you don't need a prophet to tell you. Where is this question coming from? This question is coming from where? Indices, true or false. And which of the laws is applicable to this particular question? You don't need a prophet to tell you. Is what? Is division law. So you write solution, then you write it down. 9 raised to the power of minus 1 all over 2 all over 27 raised to the power of 2 all over 3. Amen. So what you need to do with what I have taught you so far, this means, this is, what are we going to do? This is the same thing as 1 all over square root of 9. True or false? True or false? Because I told you that if we have a raised to the power minus 1 all over 2, this is the same now. 1 all over square root of a. True or false? Yeah. Then all over. Then if we have, yeah, I did not mention it to you, but if we have a raised to the power of 2 all over 3, this is the same thing as, because of over 3, it means cube root of what? 3. Cube root of a, open bracket, raised to the powers of 2. Yeah. Because if you simplify this, it will give you back this. Is that clear? So, if you can see what I am saying here, this is the same thing as cube root of 27, open bracket, raised to the powers of what? 2. Do you agree with me? So, now, this will now be equals to 1 all over square root of 9. Square root of 9 means what? Any value that you can use to multiply itself twice. So it means, how can we find square root of 9? Let's do it this way. Let's go back to our elementary mathematics. Can 2 divide 9? No. Let's try 3. 3 to 9, 3. 3 to 3 can stick on 3 to 3, 1. You discover that 3 times 9, it gives you what? 3 times 3, it gives you what? 9. So the square root of 9, since 3 into 2 will multiply themselves, it means square root of 9 is going to give you what? 3. Then all over, what do we have here? Cube root of 27. When we say cube root of 27, that it means, cube root means that value that can multiply itself 3 times, and it will give you back what is here, inside there, 27. That is the meaning of cube root of 27. So let's do it this way. Let's do it this way. Let's 27 all over 27. Sorry. So can we use 2? Can 2 come? No. It will be remainder. True or false? Let's try 3. 3 to 27, 9. True or false? Then 3 can still come, right? 3 to 9, 3. Yes. 3 can still come, right? 3 to 3, 1. You discover that 3 into 3 gives us what? 27. That is the meaning of cube root. So this implies that cube root of 27 is 3. Not 3 times 3 again. No. Please take note. Because 3 appear 3 times. So you pick only 1, 3. That is the meaning of cube root. So it means 3 open bracket raised to the powers of 2. Then note that if we have anything raised to power, let me say, if we have a raised to power 2, this is the same as a times a. True or false? So this is now, I can clean this, right? This will now be equals to 1 all over 3 divide, amen, 3 times 3. Yes, this is the meaning of this. So this is the same thing as 1 all over 3 all over 3 times 3, 9. True or false? So if you can see what I am saying, this is equals to 1 all over 3 divide 9. Note that there is an invisible 1. So now we are going to convert this division sign to what? Multiplication. So this is equals to 1 all over 3 times. If we convert it to multiplication, this numerator will now come to the denominator, then the denominator will now come up. So here will be 1 all over 9. Do you agree with me? So far, so good. Yeah. So, okay. So if you agree with me, this is equals to 1 all over 23 times, 3 times, okay. Let me just break it down so that you won't be confused. This is equals to 1 all over 3 times 9. Now, which is equals to 1 all over 3 times 9 will give you 27. So, this is indices for you. So, in case you have any challenge, any problem, yeah, I don't think you will have problem. Why? Because I'll break it down for you. With what I have said from the beginning to the end, if you understand and know what I've done here, I don't think there will be a challenge for you, because there are some questions that you will use both multiplication law, division law, power law. So for the fact that I've taught you everything, all the both zero law, everything, what is there is you must know when to apply the laws of indices. It will do you good. Thank you and God bless you. See you guys.